Okay, good afternoon, everyone, and welcome. Welcome to Industrial 369 breakout session on how TE connectivity transforms product engineering with Agentic AI. My name is Mrinal Daftari. I'm a senior solution architect here at AWS, and I had a privilege to work closely over the last couple of years with TE connectivity to help them architect and implement what I believe is one of the most impressive manufacturing agentic AI workload out there. Today's session is going to be unique because you will hear the story directly from our partner TE Connectivity. I will be joined by my partner at TE, Girish, who will walk you through about how this breakthrough transformation journey was created and how the solutions were built. When TE Connectivity approached us, they had an ambitious vision of 40,000 employees with a GenAI platform that could intelligently access over 10 million plus records and 50 plus data sources while maintaining enterprise-grade security and generating low latency response and maintaining cost per employee ratio to as minimal as possible. So let's have a go through today how TE Connectivity was able to achieve them, because most companies fail to do one or two of them, while TE Connectivity was able to achieve all of them. So here is the agenda. We will start with what we see in manufacturing AI landscape in the manufacturing, why 73% of enterprise manufacturing AI workloads fail to reach to a production, and what are the challenges that engineering document processing that requires specialized solutions. Next, we will go over on how TE Connectivity transformed the story from concept of serving few thousand product engineers to 40,000 plus users in their latest version of Tell Me. How they come up with a 99.99% uptime and a breakthrough in how 2D model readability accuracy was improved versus industry standard of 40 to 50%. The core of our session would be led by my partner, Girish, who is going to demonstrate Tell Me's agentic AI capabilities, architecture, and real-world impact with 75% adoption in engineering departments. And of course, Tell Me has now grew over 40,000 users from initial 8,000 pilot users target. We will wrap up the session with lessons learned, cost optimizations we did, and what it means for the future of manufacturing AI at TE Connectivity. So manufacturing faces a perfect storm of data challenges that makes AI solutions struggle or fail in most instances. There are three critical challenges: volume, access, and the complexity. As a manufacturer, they generate thousands of petabytes annually, thousands of technical documents scattered across the systems with millions of records requiring more and more processing. So most digitization is still manual and making it costly and time sensitive. But volume isn't a real problem. It's the complexity within those documents. We are dealing with engineering drawings, technical schematics, and manufacturing specifications that your typical or simple AI solutions cannot understand. Knowledge gets trapped in unstructured content that traditional systems fail to understand. Even when you have the data, engineers spend hours hunting for that information. We are seeing massive knowledge as experienced workforce is retiring and taking that essential knowledge with them. So when you add the enterprise security requirements on top of all this, you have an inaccessible critical information exactly when your product team members really need it the most. So what is the true manufacturing AI reality? Here's the sobering truth, that 73% of Gen AI initiatives never reach to production. In manufacturing, it's worse because standard GPT-style solutions cannot understand your CAD diagrams, cannot understand your 2D drawings. And navigating this complex engineering workflows is challenging. This is exactly what TE Connectivity faced when they set out to serve over 8,000 users from their product engineering department to access over 10 plus million technical data. So the question was whether AI can do that for them or not. The question was what sophisticated AI system we can build to help them accelerate their product engineering workloads and efficiency for their product engineering departments. That is where our true partnership began. So let me show you how these challenges could become advantages to your company when you do the things in a right way. We got sub 15-second responses across millions of documents. Think about that. Sometimes to open your CAD drawings can take longer than that. Your engineers can now query 10 plus million technical records and get accurate responses faster than ever because they have access available in sub-latency seconds. High adoption rate in engineering departments brought a great efficiency because in an industry where most initiatives never reach to 20 or 30% adoption, TE was able to achieve more than double digits of those industry benchmarks. That's the proof when you build AI that actually works for manufacturers, people will come and use it. Accelerated product design and engineering cycles help innovation quicker because when engineers can instantly access decades of data at their fingertips with the right security access, they can propel their efficiency and their new production workloads at excellent speed. Now, the biggest challenge we face in manufacturing is retiring aging workforce, which carries away preserved expertise despite of a lot of documentation available. So when you have when you have the next generation of engineers ready with such system access available to them, your growth and knowledge retention would remain intact. And finally, extremely low cost per user per monthly. At enterprise scale of 40,000 users, that's remarkable because even a $10 to $20 per employee per month is huge cost, and TE was able to achieve that cost as a fraction of that $10 to $20 benchmark across the industry. So these aren't just metrics, right? They represent a fundamental shift in how manufacturing organizations can leverage their intellectual capital. And that's what TE Connectivity didn't just build as an AI platform, but they built it the future of manufacturing intelligence for their product engineers. So how did we architect this solution that could meet these demanding requirements? I think this is where true partnership between AWS and TE come into play. We brought the right toolsets and AI ML technologies. TE Connectivity brought the right experience from the industry and the data sets accessibility for us. We didn't just implement another AI solution, we built a modern industrial data strategy from the ground up. This meant rethinking how manufacturing data flows, how it's indexed, and how it's made accessible to AI systems at enterprise scale. The technical challenge was immense, serving thousands of active users simultaneously with sub-latency and sub-millisecond latency while maintaining the uptime. This required innovative architecture, and that's where we used Amazon Bedrock for the AI needs and Amazon OpenSearch for the lightning fast vector search for searching across 10 plus million documents. We had a phased approach with measurable outcomes. We took disciplined approach where each and every phase has a measurable outcome, a planned launch, and a success criteria with measured adoption rate. The groundbreaking thing in this entire solution is the accuracy of 2D model understanding. This is where TE pushed the boundaries, and they were able to achieve greater than 90% of accuracy for technical drawings versus typical industry standard of 40 to 50%. This represents a greater than 50% improvement, absolutely game-changing for their engineering organization dealing with complex mechanical and manufacturing drawings. One of the breakthrough things we did was integrating knowledge graphs within Gen AI. So this allows Tell.me to understand not just the individual documents, but the relationships between engineering diagrams, manufacturing processes, design decisions, and it enabled the platform to provide contextually intelligent responses. On top of everything, enterprise manufacturing data is incredibly sensitive. So we built a sophisticated role-based access system. That means that users with the right access can see everything what they are supposed to. However, AI can reason based on that entire database to provide a better and accurate response within the security boundaries set by your organization. And finally, the most important thing we achieved is a remarkable cost optimization. As I mentioned earlier, after its third phase, we launched optimization techniques within Tell.me solution, which brought cost down significantly, and it was able to help proving the sophisticated manufacturing AI can be cost effective and bring more efficiency and productivity boost to your organization. So this was the classic advantage of doing a partnership between AWS and TE. Results speaks for themselves. Last year at Innovate, we did a presentation on how Tell.me was served up to 8,000 users. And today, Tell.me serves over 40,000 users with 99% uptime and an economical per user per month cost, with breakthrough engineering drawing understanding capabilities built in-house for remarkable accuracy. So you didn't come here just to hear all this from me, but I would hand it over to Girish. He will walk you through the entire transformation journey, dive deep into architectural patterns, and why Tell.me stands out in the manufacturing industry. Girish?
Thank you, Mrunal. So TE Connectivity is a leading connectivity solutions and sensor design and manufacturing company. So as you see here, we are close to 100 factories, then close to say around 90K employees, right? And around 11,000 engineering workforce, 740 million invested in our research and development engineering. So my name is Girish. I am part of TE Connectivity Singapore AI Hub. I'm Senior Software Development Manager. I'm leading a generative AI team there. We are around 7 people, 5 in Singapore and 2 in India. We would like to go through the journey of how a generative AI can transform a manufacturing company like TE, and what is the benefit user can see with a remarkable like 10 million kind of data set augmented to an LLM, plus a cost which is less than $1 per person per month. So that's the story. So we're going to start in depth through architecture as we go further. So before, how did the journey begin, right? So the question is, what is the fundamental behind this generative AI program? You have something like off-the-shelf tools. You have off-the-shelf many solutions we can hook it up. Why another generative AI tool, right? So here's the story. We started sometime last year. What we did is, TE Connectivity is a big company with multiple BUs, multiple segments, each autonomously developing multiple products. So what we did is we gathered 100+ experts and subject matter experts, AI enthusiasts, domain expert, and we said, hey, what do you want to see in generative AI in next 2 to 3 years? How do you think generative AI can apply to your domain, right? This is the fundamental block of our story. So we came through a lot of ideas that was generated by domain experts, then the people who are AI enthusiasts, they knew what could be achieved in AI. And then we said, okay, we got a bunch of lists on what they want to achieve in generative AI. And then we sort of segregated them and said, okay, this is first year, we have huge number of documents. Let's build a question and answer tool. Anybody gets in, 40,000 people in the company, they ask a question, they get an answer. That's the fundamental thing, right? So that's the fundamental point. Then we said, okay, our journey starts from there. Once you have a lot of data, what we do is we derive insights from those data. Then we generate workflows, we automate. So that's the timeline that we do. Within 1 year timeline, we have millions of data brought in, and we're going to generate insight. We're going to generate an intellectual response based on all the content that is available. we didn't knew that AI is going to do that great. It was like, okay, we thought we were going to do it. Once we brought in the data, I mean, we were surprised the way generative AI is able to seamlessly bring the insight from so many disparate systems where the data is scattered across multiple places. Once you bring in generative AI, we're able to synthesize the responses that we couldn't think of it. We were surprised, right? So that's the journey of the first year, like 2025, we launched it to 8,000 people. And then we saw something like a tremendous enthusiasm from the people. Then our next story was something like, by next year, we want to generate something like, it should be able to do something like a specific functional role, maybe something like a design review, something like design failure mode analysis, something like checking your quality audits, checking your compliance. So that's what we said, okay, by the next year, we're going to reach a goal where it's able to automate some of your tasks within a function. And then we said it should be able to create, format, generate engineering content based on the information is available. Plus, we said we should be able to use internal data that we have and bring external knowledge from the large language model and augment that and amplify the insight. Right? Those are the targets that we had in September 2025. With the launch of our own agentic platform based on AWS, we are able to hit all those targets that we have. Where do we want to go in the future, right? So that's the future we envision. Next 1 to 2 years, we want to do complete automated end-to-end task as much as possible for a role, maybe 70 to 80%. We want to identify roles and find out how much can be the role. The functions can be automated. We want to do that automation. Then generative product design. We are working on trying to find out how can we use generative AI in the product design itself. And then agentic mesh. We're all seeing about agents right now. I think the reInvent is all about what you hear is agentic AI. So we are thinking the next step is an agentic mesh or agentic swarm doing multiple things for a user, solving a complex scheduling, planning, whatnot. So that's the future we envision. We are at a point where last September, we met most of the things that we envisioned this platform to do. So these are the capabilities and examples, but very limited one. The biggest appreciation for us is not the capabilities and the outcome that we see. When people come and say, hey, we are using Tell Me, and it created an impact. Often we hear from our sales and product marketing folks, they say, or our customer service folks, they say, we used to spend a lot of time talking to engineering, talking to product marketing to find out various informations about product. We no longer need those kind of conversation. We get everything from Tell Me. That's because we have all the product catalogs in TE, all the data sheets in TE, all the design notes, all the technical information fed into Tell Me, and it's continuously updated. So the biggest appreciation for us is somebody comes and says, hey, it made an impact for us. So now, typically it used to take a week plus to talk to your engineering, talk to your marketing, finding out what should be your response to customer. No longer that's the case. Our sales, at least whatever I heard from our sales teams were very exciting. They say, I no longer need to reach out to many people to get an answer. I have Tell Me, right? So that is the fundamental shift we are seeing, where the information that's being fed is transforming the user's day-to-day work. So what are the capabilities of this tool? You can do single file upload, ask for insight. You can upload multiple files, up to 20 files in a session, and ask for insights. Then you have an internal data that is basically our own 10 million records, and both structured and unstructured. Then get information from them. Then there is an external mode. It typically works like any other generative AI tool which makes directly call to the large language model. Then AI agents, people can create their own agent. Any 40,000 users in our company can log in. They will be able to create their own GPTs and agents and share with their colleagues at no cost, no license fees. They can just share. They can create and share. This is the way we are seeing the work is transforming. People are being very creative. If you ask me what is the use case, I might be able to think only 4 or 5. But now with this power to the users, they are building their own agents. They are building, the imagination is the limit. That's the transformation we are seeing where everybody can create agents, share agents, and everybody can create and share agents to the public. Entire 40,000 people in the company at no cost, at no license fees. Then there's a gamified teaching assistant for prompting. This is the biggest challenge. I'm sure most of you agree, right? People are still in a Google search era. They type one word and they expect answer to come through. But generative AI is not like that. It depends on how best the prompt is. So we got to shift entire our user base from Google search era to a generative AI era. And it's not so easy. I'm sure you would have seen in your companies, it's not so easy to shift that mindset. So what we thought is, hey, why not we gamify this? So what we built is a gamified kind of agent where people can log in. They say, I am a product manager. I am at a beginner level or expert level in prompting. So it will sort of start giving you questions, multiple choice questions, and give you points. If you answer right, if you answer wrong, it will give you explanation what should have been, it could have been done better, and what are the prompting principle you should correct yourself. So with that, it becomes an interactive teaching. At the end of the month, we collect all the points, how many points people have got, and so we publish the winners. So this is where we're trying to sort of increase the awareness of prompting in generative AI era through gamification. Then SharePoint integration is basically ensuring that agents have right access. People who are using the agents, that knowledge store, they have right access to the SharePoints so that nobody can sort of upload files which are like arbitrary, which doesn't have any security control. So this is security and enforcement integration that we have done for SharePoint. So we have almost like 99.9% availability, never went down from the day September we have launched last year to this year. Not even a single day, single minute it has gone down until when we want to upgrade the system. It has never gone down, never failed, not even one component. 15-second time for first token across globe, typically around 6 seconds. That is searching across 10 million records and responding to users, typically 6 seconds. With an open search, it's possible. I'm sure you would have probably see this kind of questions. Hey, what would be the latency if I have so many data sets in my company? Right? With open search, it's possible. It's possible to get a response of 6 seconds. And we don't make just one open search call. For each query, we split that into 20 to 30 calls to open search, multiple parallel calls to open search, and all that happens within a second or two from open search. That's the kind of, it amazes us, of course. We have not built an open search. We always say we are thankful for the AWS folks because it's very robust. Accuracy is pinpoint. We don't use any re-ranker because the plain out-of-the-box solution from OpenSearch is damn good. And latency, 20, 30 calls going parallelly for a single query to OpenSearch, and less than a second, a response from OpenSearch. So those are the powerful features that has enabled us to reach out to 40,000 people. So now, the architecture piece of it, sorry, we are not sort of sharing that with very clarity. If you see the left-hand side of it, it's all about security. logging into the enter ID, single sign-on, and once the user logs in, it has to know the user. Suppose if I am a class 1 user, I have access to class 1 document, I have to see only responses from class 1 document. Out of 10 million, I should only get responses for class 1 document. If I am a class 2 user, I need to get only responses from class 1 and class 2 document alone, nothing else. So that's the second piece on the security side, where we have role-based access control implementation, where we have when user logs in, it not only authenticates the user, it also gets what is user's security role, whether he's a class 1 user, whether he's a class 2 user or a class 3 user. So we take that information back, and internally we process with OpenSearch database with a role-based access control mapping. So suppose if somebody like a class 1 user logs in, it will give him an answer. Hey, this is the answer for you from the database, whatever class 1 data. And at the end it says, you have more information across 30 documents, but you don't have access to. Please reach out to your colleagues or your supervisor if you need more information. That is the power of security that we have built in. Right? This is where most of the organizations struggle, data security. Right? So our security first design principle, our forward-looking security postures have always made this product a success, where only people with right access, with the need to know, will get the information, no one else. On the right-hand side, what you see is our data pipeline, where we have millions of documents brought in. Then whenever documents get updated, deleted, it sort of checked out and then refreshed. That's our data pipeline. The centerpiece is about all AI, agents, the GPTs, the Lambda functions, all that stuff. So typically, what do we have? Right? So typically, we use OpenSearch vector database, which I said, which is one of the best I have seen. Then we have Aurora DB for general logs and sort of ingestion pipeline management. Then we use Redis vector store. That is because when user uploads, say, 20 files to ask a question, that goes to Redis vector store. So we dynamically push the data to Redis vector store in that session. We bring those 20 files back and put it to quadrant vector search, and then we generate the result. Then, of course, we use Bedrock API. This is our fundamental shift that has happened over past 1 year. We sort of harmonized all our API calls with Bedrock API, so that any moment we need to switch a model for our agents or for our use, be it Amazon Nova, be it GPT 128B open weight model, or be it Claude, we just change by one word. Right? So that's the harmonization that we did to bring Bedrock API standardization calls. Then, of course, Amazon Titan we use for embeddings. Redis streaming, this is a major thing. This is where we had a strong partnership with Brunel. When we started, we were supposed to be something like the 150 people kind of POC. Then our management said, hey, we need to go to 8,000 people, not just 150. And that was a 14 weeks end-to-end delivery. Right? And then we came to Brunel, and we came to AWS and said, hey, we got a request to make it available for 8,000 users. And that's a big ask. And somebody, if you have developed a large language model, something, an application like this, there is multiple trade-off. Token per minute, request per minute, then context length, how much you can serve an user, right? So you have certain limits within something like within a minute, you can only do 2 million tokens. If your 10 users are consuming, talking, the rest will be throttled. So how do I support 100 people, 200 people? So these are the architectural bottleneck that we see when we want to build an enterprise-grade generative AI tool. So this is where we spent a lot of time with our AWS folks trying to figure out how how robust enterprise generative AI tool can be built. This is where we sort of came up with the thought of using Redis streaming, a WebSocket streaming, rather than using a just Lambda function to stream an output. We had Redis, one of the fastest reliable streaming. We use a WebSocket streaming there. It serves like 100+ users at a time, concurrent users at a time without any glitch. Then, of course, EC2, ECS, API gateways, S3s, Lambdas, most of those things, Control M, you guys know because these are the standard things we use for pipeline management, front-end, back-end software. Right? The core elements are this, right? So these are the fundamental blocks that we use today. And of course, you probably see an addition of Agentic Bedrock core as we move forward here. This is something very exciting that we see as on date. So that gets in. Then we had a partnership in the beginning. Like not everybody got the token limits or the rate limits as they wished, right? Everybody was developing, cloud was developing, they had their own limitations. We had very, very limited tokens, something like a 1 million token per minute, but we had to serve 100+ concurrent users. With all the token limitations with LLM, we cannot move forward with an enterprise-grade software. So this is where we work with Mrunal and the cloud team for extending those limits for us. That's pretty much about architecture. So now this is how the tell me looks like. So you can see a teach me agent there. So we have 40,000 users, right, who have access to this tool. We have 7,000 to 8,000 active users every week, close to 800+ active daily users using the system. 10,000+ file uploads every month, which is growing. We are hoping that it will sort of keep doubling every 2 to 3 months. 10,000 file uploads. I mean, 10,000 file people are uploading and asking questions about generating insights. It's not a small thing, right? For an enterprise-grade generative AI tool, that speaks the volume. Then month on month, 60 to 80% of user retention. I mean, 80% of the people who logged in previous month, they log in next month. So these are the, and of course the adoption which Mrunal talked about, close to 74% of adoption in engineering, which is big. We also have active feedback collections, and you can see there is a prompt library, because this is where we want to teach people about standard prompts, recommendation, how to use it, and all that. And this first one, that's fusion of internal data with static LLM knowledge. If you see any conversation at the end, we have tell me leading the user, hey, do you want to also see external content on the search that your result you got? So we lead users not only take internal data, but also gather any external information that is available from static LLM knowledge. Quick insights. So tell me 3.0, which we launched in September. All the capabilities, something like 10 million records and document indexed across the platforms. Then 40,000 users. File processing, multi-file upload capability, and as I just spoke about, 10,000 file uploads per month, and it's growing constantly. The internal mode and external mode to fusion, to bring the fusion of internal data with external large static language models data. Then key is security first posture. Having a role-based access control is the key for any generative AI enterprise-grade software, because I'm sure many organizations will have data security team. They are worried about the amplification of data when it comes to AI, right? So they need to ensure that security is built in. So our posture of having a role-based access control, security first, has always made this platform secure. Reads engineering document, the engineering drawings. We have built our own advanced model. traditionally, if you ask an LLM, large language model, be it Claude or be it ChatGPT or be it any other LLM in the world, if you upload a 2D drawing and ask the insights from it, most likely you will not get a good response. If it is plain simple one, yeah, most of the LLMs will do. But if it's a complex drawing where you have huge number of dimensions, up to 200 plus dimension in a drawing PDF, most of the time they are rotated, 45-degree angle turned. Some of them have the bubbles for markup. Most large language model fails to meet even basic accuracy of 30%. So this is where we built our own models, fine-tuned our own vision transformer models to enhance the accuracy of what we see today in LLM. Our own models now generate an accuracy of close to around 70 to 80% for complex drawing. For normal drawing, it's always now up 95%. So this is a significant transformation because a manufacturing company like TE or any industrial company, whenever you have like 100 plus factories, the design is basically your CAD data in 2D drawing. So it's something like the way you read PDF, our tool is now able to read the design drawing. So that's the power that we bought, of course, with significant help with Amazon folks on infrastructures to train those models and other stuff. Then agent development, which we spoke about, we probably will see as we move forward. You can see here the right side the GPTs. ChatGPT calls them GPTs. Copilot calls them agent. LangChain Studio also calls them agent. Right? So it is basically all of that in TellMe, where people can build their own GPTs or agents and share with others. So that's the democratization. Basically, anybody can build. We are bringing the power to the 40,000 users. So this is how our GPT looks like. You have basic thing like your GPT name. You have the instruction for the agent to follow. This instruction, what you see, is a small one. We have something like 200 to 300 pages of instructions written there for agents to follow. Then we have tool selections, be it a web search, be it internal search, external search, or automatic file generations. So all the capabilities, as we build tools, the GPTs get the capabilities. So people can attach the tools that they can run. And then we have something implemented, something like a smart document analyzer, which is another significant step. If you have 20 files, and if you ask a question, because of context limitations that we see generally, we don't get a good response. So we have something like a smart document analyzer, which will do multi retrievals to help the accuracy of accuracy when you have more than 20, 30 files in the system. So this is now something like last month we launched. People are very creative. They are building and sharing their own agents across the company. So that we can't imagine how much productivity it brings in to the company. Key outcome, 40,000 users experiencing generative AI at a minimal cost, less than $1 per person per month. That is significant. That also tells us probably what is the real price of the commercial tools. Right? So with the partnership from AWS, of course, it's not that we are in this position $1, less than $1 per person per month from the beginning. Right? We had huge cost when we had the 40 million records, 10 million records, 40 million vector indices in open search. The cost was huge. So we tirelessly worked with AWS for 6 months, to get the cost to 1/10. You can't believe it, right? 1/10 of what it used to be. It used to be higher around something like a 50K, which came down significantly, 1/10 of it, with rigorous optimization on
Vector.
embedding reductions, then using something like a non-HA infrastructure, then packing the information to the each vector indices. Most of the time, if you would have followed the general guideline outside the world, or something like got some information from say any code development tools or outside, your chunking strategy won't be optimal. Titan embeddings can support up to 30,000 characters, but when we look deep into each vector embedding, it was hardly something like 10, 15 words in one vector embedding. The chunking strategy, what you all see in web, it's not the real ones. So real one comes through engineering, optimization. So that's where we work closely with Amazon. What we were seeing is something like just for 80 words or 50 words, it used to be a vector. We worked rigorously with AWS folks on how do we optimally pack enough information in one vector indices, right? So we took that to close to almost like 8,000 words in a vector indices compared to 80 or 100 that are used to be. So that is a significant reduction that we brought in. So without all that, our cost of our open search for a 10 million record is 1/10 of what it was in the beginning. So with all that optimization, our costs are less than $1 per person per month. So this is a significant achievement, I would say, in this entire story. As I speak, it's a one-stop solution for our customer service and sales folks, because all the product database, product information, catalog, everything is there. Even just they enter the product code, some numerical, say 12-digit character, they can get all the details of the product, including its specification. All they have to do is just enter the part number or the ordering code, which is all just some numbers. And we didn't feed that into Tell Me. We just fed the document. And we use the right embedding, we use the right tokenizers, we use the right PDF extraction tools. People just enter some 12 or 13-digit numbers, and they get all the insights about ordering code, product specification, product key information, what are the key applications, everything that comes in like in blink of an eye. That's the power that we have. So what are the lessons learned in this journey, right? Cost optimization is a way of life. Don't get scared if you see the costs are ballooning in the initial stages. So it will be, right? So continuous optimization is the way of life. Today we are in far better place. If anybody is saying there is 10,000 document file upload and there is a 10 million records and sub latency of something like a less than 15 seconds at a cost of less than $1 per person per month, it is significant achievement. And that has happened not one day, it has happened through the journey of past 5-6 months with our Amazon folks. User enablement. This is the biggest challenge most of you would have been facing, right? How to train our people. Prompt trainings are essential. So we have created curated content, we have trained people, we have enabled multiple training sessions, close to 20 plus last year, to help people understand 5 or 6 prompting principles. How do they use? We continuously publish this information. We have internal our own Viva Engage, where we have recently 1 million active views on those portal. We teach people. Quite often we keep teaching, but it's not enough. We hope this is a journey, like our cost optimization journey. There's a point where people will become expert. But if you are in the journey, right, this is something that fundamental we have to pay attention to, for sure. Technical complexity. This is the basic assumption people will think, okay, it's a wrapper around cloud model or wrapper around OpenAI model. It is not. Real engineering gets into a lot of depth to achieve what we have done, including balancing the context windows, balancing the token constraints that we get from Claude or any other generative AI model, the response quality. So all those things, it's like the complexity is huge. You need an expert AI team for sure to have that. Data quality, right? So this is the biggest challenge that everybody will face. More the LLM knows, it's also more problematic. The reason being, it start trying to pick pattern from your data and start answering the questions. So sometimes we think it's hallucination. We ask question back to the large language model. Hey, why did you give this response? It's not right. Are you hallucinating? It tells, no, I picked it because there is a pattern of this data with respect to some other data set that I have seen. I am seeing a pattern. That's the reason I felt this is the right answer to do. Now, you can control hallucination because you have prompting techniques. You can fix hallucination, but how can you fix pattern picking up by LLMs? It gets tough. So the real engineering begins when you have more and more data, where you have to control the large language model and its behavior. That's what people face when they start from small to become like an enterprise-grade software. That's where people start learning. And this is where we are learning how to make this better. Accuracy. This is the biggest challenge, and for the future, I am sure with the Bedrock Agentic core coming in with input with validation, it's a big step. Often we get questions from users, hey, is it accurate enough? How can I trust this? Right? So what we do internal validation step before the answer. Even with that, we see 86, 87% accurate. Right? How do you make sure that it's very much 100% accurate? Especially with agentic AI, when you have to make a decision, these are not good enough numbers. 80% are not good enough number. You got to be very close to 99%. So this is the challenge that we are learning. And what are the evaluation framework for a generative AI responses, be it RAGAs or be it something new evolving. So we are trying to evaluate all those changing landscape in the technology. We try to sort of bring them in and try to learn what is the best. And it was encouraging to see Bedrock Agent Core with an validation thing coming in, right? Hopefully that will solve our problem. We don't need to go out and then bring an open source framework to all that validation. With that Bedrock agent, we should be able to solve the problem now. So now again, what is the agent effectiveness? So what is the ROI? So these are the framework that we need to build, and we will probably mature as we move forward in this journey. So with that, I would like to say thank you for listening to us, and we are looking forward to have meaningful conversation with the expert like you. Would love to learn from what is going on with your organization, with yourself in terms of generative AI. We would like to learn more and probably share more. This is where we can grow together. And thanks for being here. Much appreciated. I'm handing over to.
Thank you.